Hello my dear students, as in the previous video, I promised you to come back with numerical problems on combination of resistors. So I am here again and request you to watch the video completely. Those who missed to watch my previous video on theory and derivation of calculation of equivalent resistance, please click the link of my previous video which is given under the description box under this video. So let us start to understand how to solve numerical problems on equivalent resistance. Okay, we start with simple circuit and gradually we go to the complicated circuit, but obviously as per the level of grade 10.
Let us start with a simple combination of resistors, that is the series combination of resistors first. Here in the diagram you can see that 12 ohms, 10 ohms, 14 ohms and 13 ohms, 4 resistors are combined in series. So how can we find out the equivalent resistance of the 4 resistors? Now let us remove the 4 resistors 12 ohms, 10 ohms, 14 ohms and 13 ohms. Now what is the equivalent resistance? That is the sum total of the 4 resistors, that is equivalent resistance equals to 12 plus 10 plus 14 plus 13 ohms equals to 49 ohms. So let us now take another example where 4 resistors of values 5 ohm, 10 ohms, 15 ohms and 20 ohms are connected in parallel combination. If we replace the 4 resistors by a single resistor of equivalent resistance, then reciprocal of equivalent resistance is 1 by 5 plus 1 by 10 plus 1 by 15 plus 1 by 20 equals to 25 by 60. Therefore, equivalent resistance of the combination is 60 by 25 ohms equals to 2.4 ohms. This is a network of resistors. It looks complicated, but don't worry. Start and go on. The network of resistors will be easier and more easier. So let's see what and how we can reduce it to smaller and smaller. Resistors of values 10 ohms and 2 ohms at the right side of the diagram are in series combination. So this can be replaced by an equivalent resistance of 10 plus 2 equals to 12 ohms. Now the 6 ohm resistor and newly connected 12 ohm resistors are in parallel combination. So those resistors can be replaced by an equivalent resistance. So equivalent resistance of 6 ohms and 12 ohms we can calculate, that will be 6 into 12 divided by 6 plus 12 equals to 4 ohms. Now the 4 ohms resistor and 8 ohm resistors are connected in series. Okay, so these can also be replaced by equivalent resistance. Now 6 ohm and 12 ohm resistors are combined in parallel. So these two resistors also can be replaced by their equivalent resistance. Now two resistors of 4 ohms each are connected in series. So these also can be replaced by their equivalent resistance. Equivalent resistance is 4 plus 4 equals to 8 ohms. These 8 ohms and 8 ohms resistors are combined in parallel, so can be replaced. Equivalent resistance is 4 ohms again. Now remove these 4 ohms and 4 ohms resistors as they are in series combination. Circuit is now very easy. Now 8 ohms resistors, 2 8 ohm resistors are combined in parallel. So replace these two also by their equivalent resistance. Final equivalent resistance is 6 plus 4 equals to 10. So friends, I think you have an idea to solve the numerical problems of equivalent resistance. If you have any doubt or need clarification on this topic, please write me in the comment box. Thank you for watching the video.